Okay, so last time I assigned you a project, which was that shape calculator, if you will. How's everybody doing with that? Any major questions, concerns? Okay. Does anybody need any extra time? I'd be more than happy to extend the due date by a little time.
Actually, I had a quick question.
Yeah.
So, on one of the equations, I forgot what it was. So, I think I think it was pi r squared. But I didn't know how to like square the actual like radius, so I just did like the radius times itself. So, is there a way to like actually square it without doing what I did, like
There
the
is.
radius times itself?
There is. What might be your guess? Even if you couldn't say how to do it, what might be your guess as to how you might do that?
See, I thought that you did like the little caret and then the two,
Okay.
but like that's what I got.
Okay. Did you do any research into that?
A little bit, but
And what did your research turn up?
well, I don't really remember honestly.
Okay,
Yeah.
that's fine. Yes, it can be done.
Okay.
I will leave it to you to figure that out. I actually think the way that you ended up doing it is the way I kind of would expect you to do it. Um, Mostly because why would you guess that might be my thought as to how you would approach it?
Because I would think just because it's easier just to do that.
Okay, yes, I would say that would be one thing about that. The other thing would be that's how you're taught to do it in math, right? Like when you don't have the ability to square thing, like even though that's what you're doing, you don't like have the ability to like square something without a calculator other than timesing it by itself, right? Which is exactly how they tell you to do it. They tell you to do pi times radius, right? So yes, can be done, and if you would like to research that and do it that way instead, absolutely fine. But the way that you did it is exactly how I expected you to do it. So excellent, fantastic job. I will extend the due date just a little bit, so everybody's got a chance to get that in. Please get it in if you have not already. So today we are going to go over classes and objects. We're going to go over namespaces, multidimensional arrays, and date time. Okay, so. This is where we start getting to do some fun stuff, because once we have a grasp of all of these basics and how they're done in C#, and I'm confident that we can all do it, we can start watching videos on Unity, right, and actually start doing some visual things. Now, I need to stress that as a present, there are no game studios anywhere near us. At least not any ones that are big enough to make any kind of a splash. Now there used to be two in Springfield, but they both went away. However, it is my hope and my dream that you all will acquire the skills and the knowledge and the comfort in working with one another and that sort of thing. That you can open your own studio if you'd like to. That you can take those skills and maybe go work for like a school district making like interactive games and other sorts of interactive media for them and things like that. Maybe even go to the Discovery Center and work for them and make like a computer science exhibit, be like maybe the director of technology, something like that, and use some of those game design skills. I say that to say that the purpose of our program here is to prepare you for the workplace, right? To give you workplace skills. And so I have to always I want to make sure that I am being true to that mission, but also doing things that you enjoy and finding ways to give you immediate feedback, right, on your skills and things like that. There's plenty of time in C#2 for us to get into how to do visual things in Visual Studio and how to do really complicated things like multi-threading and that kind of stuff. We'll talk about all that next semester. But this semester, it's kind of nice because a lot of you were also in intro to game development, and so there's a little bit of a bleed over between those two classes. So anyway, once we've got those basics down, we'll be able to start incorporating a lot of this stuff into doing some basic games in Unity. Now, one final note that I will say before we start watching these videos is once we have those skills and we start doing things in Unity, it's really neat how complex your game can become very quickly. And I don't mean that in a negative way, like that you'll be overwhelmed or anything. It's just really cool that Unity will do a lot of the heavy lifting for you, right? and you can just go in and specify variables, and specify some functions to say, when this happens, make this other thing happen, and that kind of stuff. But in terms of doing all the really complex physics and collision detection and things like that, that's all built in, right? And so one nice thing about doing it with Unity is it's a nice introduction in how to do visual things with C#, because when we actually do start doing things with Xamarin, when we do mobile app dev, and things with just regular desktop applications in Visual Studio, and when we start doing ASP.NET, so web development using C# and stuff like that, a lot of these same principles will apply. Obviously, there are some commands that are specific to the Unity engine, but a lot of the same concepts will apply, because in most of those instances, Microsoft has provided you with all these vast libraries of code that you just have to invoke by saying, call this method, or apply this method to this object, or different things like that. And so I feel like it's a good way to kind of get your feet wet in working with other people's code that enhances C# well beyond your beginner capabilities. Does that make sense? Cool. Awesome, awesome, awesome. So without further ado then, let's check out how to create classes and objects in C#.
When we create projects using C#, we're going to have to create classes at some point, because we use classes as blueprints in order to create many different types of objects inside our project. So in this episode, we're going to be discussing what exactly classes are and how we can create them. For the sake of this episode, I went ahead and created a small diagram to sort of illustrate how a class would actually look like if we were to create a class. Now, you should see a class as a type of blueprint, and based on that blueprint, we can create many different objects that are just copies of that specific blueprint. It's kind of like building a house. You have a blueprint of how the house is supposed to look like, and then the construction worker can go ahead and start building many different houses based on that blueprint, and that's basically what a class is. Now, I will be looking down here when I have to describe this diagram, because on my screen it's over there, but on your screen it's going to be over there, so just so you.
Real quick, are you sure we didn't watch this video?
Actually, I think we did.
In this class this semester? I feel like we did.
I think we watched it on Wednesday.
Yeah, I think we did.
We did watch it. Okay, I thought so. I thought so. Okay, did we watch the namespaces one too, right? Or no?
I don't. Maybe.
Okay, let's start that one. We'll find out. I got all jumbled up. I could have sworn, and then you said no, we didn't watch it. So I said, oh, okay, well, must be mistaken then. Okay, so as soon as I start this, I know we did. I know we watched this one already.
We're going to have many
no,
different
we'll find
classes
out.
inside our project, and putting them all inside one file is not really a good idea to maximize our workflow, because we need to scroll and scroll and scroll in order to get to the different classes. So grouping them in different places inside our project is much better to do. So when we create a new class, it's a good idea to put them inside a separate file so we don't get them all mixed up together and have them all inside one document. And the way we do that is by going over to our Solution Explorer window, which is over here. We right click on our project, which in my case is called First Project. Then we go down to where it says Add. Then we go down to Class. And then you can see it opens up a new little window here. Then inside the pop-up, we want to make sure we choose the C# class that we have over here. And we also make sure to give it a name. So down here, we could call it something specific, like right now we're making a class that is called Person. So maybe we should actually go ahead and call this one Person. So we're going to say Person, and then just go ahead and add it here. Now, of course, we also need to go ahead and add in the actual class that we created before. So we're going to go back inside our program file, and we're just going to go ahead and copy the class and then just delete it. And then we're just going to go ahead and move it inside the new file we created. So we're just going to go and replace class Person with our new public class Person that we created in the previous project here. Now, one thing you're going to notice is when we create a new class file, they're all going to end up in the same namespace. So if we were to go over inside Solution Explorer.
Okay, so we have seen this one as well. Okay, cool. Okay, so I know for a fact we've not seen the date, time, and the multidimensional arrays. I know that we haven't done that. Right, okay, perfect. All right, so in that case, let's switch over and check out multi-dimensional arrays, and then date time. Sorry about that. When you teach multiple sections of the same class over the multiple semesters, you tend to see. I've seen this video a billion times, so it's like I can't remember who all I've shown it to. So let's check this out.
So today we're going to talk about something we have talked about slightly bit before in the previous episode, which is arrays. Because when it comes to arrays, which you might know from other programming languages, we have something called multidimensional arrays. That simply means that we can put arrays inside arrays and then add multiple pieces of layers of data. So I'm going to show how to do that inside C#. So as you can see in front of me here, I do actually have the example we had from the previous episode where I just talked about arrays. And we had this example where we created an array that was a string of names, and we just had 4 names inside this string of names. So as you can see on the screen here, this is the exact same example as we had previously. So the idea here is we can create something that is called a multidimensional array. And there's a couple of different kinds we can talk about. There's something called a rectangular array, and then there's something called a jagged array. And it just basically means that we have one type of array that has the same number of rows and columns all the way through. And then there's some types of arrays that might have different types of, number of data inside this it simply means that we can have different sizes of rows inside the different columns inside the multi-dimensional array. So scrolling down a little bit, you can see I created a rectangular array, which is the one that we can create where we have the same number of items inside each row. When it comes to the columns, you might have inside a multi-dimensional array. So to give an example here, you can see that I created a new array, but we create them slightly different when we create multi-dimensional arrays. Instead, we just simply create a variable. We set it to some kind of name. In this case here, I call it names list. And when we have to define the number of data that is going to be inside the array, before, in a regular array, we would actually just define that we have 4 pieces of data inside of it. When it comes to multi-dimensional arrays, we need to define, first of all, how many columns do we need to have inside this multi-dimensional array, but also how many pieces of data are going to be inside the row, inside each column. So to give an example here, you can see that I created a new string array. So this is going to be a multi-dimensional array with strings, and I want to have 4 columns, and I want to have 2 pieces of data inside each row inside the columns here. So going down, you can see I started my curly brackets just like we did with a regular array, but instead of just start typing data into the array, I created a second pair of curly brackets with the data inside of it. So because I said I was going to have 2 pieces of data inside each row, I decided to put 2 pieces of data, which is going to be the name of the person and then how old they are. And then on the next line, followed by a comma in between them, because we want to make sure we separate them. I just simply created another row of data. So we actually created 1, 2, 3, and 4, which is what I defined in here, pieces of columns that has data inside of it. So you can kind of see how it makes sense there. Now I do also want to show how we actually output data, because you might be thinking, well, how do we actually get the data out from this array if it has like these multiple dimensions inside of it? When we do want to write it out inside our console, what we just need to do is we need to go ahead and write the name of the array, or the multi-dimensional array we have here. And then we need to first of all define which column do we want to get data from, and then what number of data are we trying to get here. So in this case here, I'm going to column 1. So we start from 0, 1. So this is the one I'm trying to get something from. And then number 0 is going to be the first piece of data, which means I'm going to output John inside the console. So it's really that simple when it comes to outputting stuff from these multi-dimensional arrays. Now I do want to point out that we can add even more dimensions to one of these arrays. So as you can see right now, we just have 2 dimensions. We have 1 and 2. And if I wanted to, just to scroll down, I can actually go ahead and add a 3rd dimension in this next example here. So what I did is I created just a little bit of a smaller array, just so we could fit everything on screen. So this time we have 2, 2, and 3, which means that if I go in, we have the curly brackets, then I create one set and a second set, because I have 2 dimensions here. Then once we go inside, let's just take the first one, go into it, we have 1, 2 dimensions more. So as you can see, that's defined by the second 2. And then inside each of these, I have 3 pieces of data. I have the name, I have the year, and I also have what eye color the person has. Now, I know I sort of repeated the data here, but it was just to sort of give an example. So you can see I have 3 defined for 3 pieces of data. And again, it's the same thing if we have to output this inside the browser, we just define, the dimension that we're trying to access. So in this case, it's going to be number 1. So we go in here, this is 0, 1. So this one down here. Then I want to get number 0, which is the first one, which is this one right here. And then number 1 is going to be 0, 1. So I'm outputting 28 years old inside this example here. Now we do also have something called a jagged array. Now what you'll notice is that if I were to go back up and just look at the previous example, you can see that every single time we go into the furthest in part of the array, the furthest in dimension, you can see that we have 1, 2, 3 pieces of data, and it's the same way all the way down through all the different dimensions. So if I want to say, well, what if I don't want to have the eye color on this first guy up here, but I want to have it on the second guy, then how are we going to do that? Because we have to predefine it inside these brackets here. Well, in this case, we create something called a jagged array, which is slightly different. So what we start doing is we do the exact same thing. We first need to create a variable, we give it some kind of name, and then we set it equal to new, and then the type of data that we want to create in here. In this example, instead of strings, I decided to create numbers, so integers. And the first thing we need to do is we need to say, well, how many columns do we want to have inside this dimension here? So in this example here, you can see I decided that we're going to have 4. And then you'll notice that I followed it up with a empty brackets right next to it. So the reason we did that is because, as you can see at the side, we're going to have 4 dimensions inside this array here, or inside this multi-dimensional array. So further down, I then create a line of code where I say, okay, inside the first dimension, inside the first one, we're going to be having 2 pieces of data inside that one. Then in the next dimension, which is number 1, we're going to have 3 pieces of data. Then in the next one, we're going to have 1 piece of data. And in the last one, we're going to have 3 pieces of data. So we simply define the rows, like how many pieces of data we want inside the rows, by setting it equal to whatever is inside the brackets here. So in this sort of way, we can define, how many pieces of data we want to have inside each row. Now, in order to actually fill in the data, because you may notice that I haven't actually created this mess that we have here, like this tree of data inside the second example. And that's because when we want to insert data, we do actually need to say, well, inside the first dimension, I want to take the first spot where we're going to have data, and I want to set it equal to some kind of piece of data. So in this case here, that would mean, if we were to take the previous example here, that would mean the first dimension and then the first piece of data, if that makes sense. So that's how we fill in the data. And then you can actually see I just create a second example where I fill in the next piece of data. And again, we can do the next one. So we can say in the next one, there's going to be, another piece of data. And if we want to fill in the next dimension, we just simply, well, actually in this case here, there was only going to be 2. So we can't actually do that right there. We do actually need to jump to the next one. So here we would say, then the next one gets filled in. So there is a way for us to do this. It is slightly more complicated when it comes to jagged arrays, but this is how we can do this if we want to have multi-dimensional arrays that has different, number of data inside of it. Now, the way we access it is actually wrong down here. This is not how we do it. It is actually by referring to the brackets that we created. So in this case here, I want to access the first dimension, which right here is number 0, so the first one. And then I might want to access the second data inside of it. We also want to make sure we create names_3 because that is the right name for it. So in this way here, we can also go in and we can grab data from this array here. So this is the basic idea when it comes to multi-dimensional arrays. It is something that you probably will use in the future quite a bit when you get to more complicated projects. For now, we're not going to continue further with this until we actually get to another project. But it is something I thought was nice for you to know about when it comes to arrays. So I hope you enjoyed this episode, and I will see you in the next one.
Okay, so The last little part of that is a little beyond the scope of what we need for this class, but or at least for what we need for our purposes right now in this class. But when we start working with JSON and different things like that, multidimensional arrays will definitely show up. When we get to C# 2 and when you're in the workplace, multidimensional arrays will show up all the time. Now, that doesn't mean that you need to have the world's most in-depth working knowledge of them because you're going to use them every second of every day. But you definitely need to understand the foundations of it. It's kind of like when we talk about like binary or like, you know, bits and different things like that. It's not, no one's going to pop in and quiz you on that, but you need to have the basics of it down because it will build a good foundation for more relevant but related things that will come later, right? Okay, so now we are going to check out how to do date and time. Okay, date and time.
So we've gotten to a point inside our lessons here where we need to start talking about something called date time. And date time is a built-in struct that we have inside the .NET framework that allow for us to work with dates and times. So we're just gonna sort of go over what exactly it is and how we can use it inside our applications. So as you can see here starting out, I created a variable. I just call it date1, and then I set it equal to a new date time. So because we have this built-in struct inside the .NET framework, we can just simply create a new date time object by referring to the date time struct we have inside C#. So what I can do is, because this is a constructor, is I can actually pass in a couple of different parameters to sort of define what sort of date time I'm trying to create here. So the basic idea here is that when we create this new date time object, we create a new date and time that we define ourselves. So as you can see, I filled in a couple of different parameters. I filled in a year, you know, a date, time, and so on. If I were to actually run this inside my application, do note there will be a couple of different things inside the console here. You just need to know that the top one up here has a specific date that I set inside the parentheses, or inside the parameters. It is right now, according to this one, I said the 1st of May 2008, 8:30 and 52 seconds inside this thing here. So knowing this, you can see that we can actually go ahead and set our own time and our own date inside this datetime object. Now, what if we want to not set a date? What if we want to go in and actually grab either the current time or tomorrow's time or something else, you know, inside this specific datetime object? We can do that as well. So what I went ahead and did here is I created 3 more variables called date2, date3, date4, you know, just to sort of have something. And I went ahead and set them equal to our date time and then a property inside the date time that we have inside the .NET framework. So what I can do is I can go ahead and say, well, we have a keyword called .now in order to get the current time and date. We can also get the UTC format of the current time. We can also get something called today, and if we just go ahead and run them, you can see what they do. Again, I have to drag it over every single time. You can see that we get the current date and time. We get the current date and time in the UTC format, and then we just get today's date without the time included. So just a 0, 0, 0, 0, and so on. Now, something to note here is that we have many different types of properties, and I do have, if you go to the website that I used to set up this lesson here, which of course is the official website you want to go to if you want to get any sort of information regarding .NET, which is inside Microsoft website. So if you go in here, you can actually see we have many different types of properties. Let me just scroll down and find them here. Or we could just use the shortcut on the side here. That might be easier to do. But as you can see, we have many different types of properties we can use. I'm not going to show all of them. I'm just going to tell you that this link here, which I'm going to leave in the description of the video, does actually have all the different properties and methods and so on, if you want to just sort of play around with this a little bit more. So going back inside our application, we did actually check out what they actually did inside the console. So let's go and talk about a few of the different methods that we have inside the date time that we can use inside C#. So when it comes to, let's say I want to add or subtract a day or something, maybe an hour to the format that I have in here, what I can do is I went ahead and grabbed the current date time, you know, date and time right now. And I just went ahead and took that one and I said I wanted to add a certain number of days, and it just included a 1 in here to say I want to add 1 day. I should also point out here that we can also subtract the day if we want to. And just as a bonus here, if you don't know exactly what you can add in here and you don't want to check out the website I linked there, what you can do is you can also just go ahead and start writing add, and then it comes up with all these different options here where you can choose something you want to do. So you can add minutes, you can add months, so on. It's all built into it here. So if I were to go ahead and say we want to add, let's say 1 day to this and actually run it, you can now see that if I just highlight the proper one, that right down here, it now says it is the 25th, not the 24th, which is the current day. You can actually see that because all the 3 ones above it is actually set to the 24th. So I'm just adding a day doing this. Now what we can also do using other different types of methods is we can also go ahead and just get certain formats with the date time. So we have something called toLong date string. We have something called toShort date string, toLong time string, and toShort time string. So if we were to run these, you can also see that if I were to go in here, you can see that we get different formats. So the first one, which is the one called toLong date string, is actually going to give us an actual day, so Tuesday, the 24th of September 2019. And then you can see we sort of change the formats here underneath. So it just sort of like if you want to get certain days or if you want to get certain times, you can do that using this in here. So having talked about the different formats, there's one more thing I want to talk about, which is the fact that we can also set a custom date format inside when we want to do something with dates. So if I want to get the current date and current time, because we also work with time, I can actually go ahead, if I want to, go inside and use the toString method, and inside the parentheses define a certain format that I want to print out using the toString format. And I do have another link here that I will also link in the description. So if I were to go in here, you can actually see that I have another link that actually spells out what the format is. So in this case, it would be a non-capitalized D that would then give us this date here. So having used some of these letters, I actually went ahead and created the year, the month, and the day. And if I were to run this, you can see we now get, if I were to put it over, we get the 19/09/24. So it's 2019, it's September, and it's the 24th. That's basically what we're getting here. So there's quite a bit here you can play around with. And again, I do really recommend that you go inside and check out the links that I leave in the description so you can see more properties, more formats, or more methods if you want to work more with this date time here. And I think this is pretty much what we're going to talk about when it comes to dates. We're probably going to do some kind of project using the date time struct that we have inside the .NET framework at some point in the future. So I think this is something that is worth remembering, also because we use dates and times and stuff inside applications quite often actually when we build different things. So I think this is something that's worth remembering. So I hope you enjoyed this episode, and I'll see you in the next one.
Okay, so he is correct. We are in fact going to do a project with that. It's a real simple one. It's just going to be a project where, or a program where you ask the user for their name. You then ask them what month they were born, what day in that month they were born, what year they were born, and you use date time to tell them your name is so-and-so and you are X years old. Seem sensible? Okay. We also have a second project. This one, see, today's Monday, so you'll have until next Monday to get this one done. Now, all the assets we provided to you, and we're going to watch a step-by-step tutorial on how to do this. Now, if you had 120 with me last semester, you've already seen this entire series, but we're going to watch it again. Okay? You're going to create your own clone of Flappy Bird. He's going to give you all the assets and walk you through step-by-step how to do Flappy Bird in Unity. Okay? The other one, the age calculator, that'll be due on Wednesday, because that you should be able to put together fairly quickly. Again, if I need to extend the due date, that's fine, but I'm going to set the due date for Wednesday currently. Okay, so give me just a second to get this set up, and we will work our way through this entire series, and that way we'll be able to actually start doing some really cool stuff with Unity. Okay, so if you would like to open up Unity, you don't have to, but if you'd like to open up Unity and follow along, uh, go ahead and do so. Now, I should probably, before we get started, so that we all know what's going on, I am going to grab the link real quick, and I am going to put it up on Canvas so that you all can go ahead and do this. Week 3. Okay, if you hop onto Canvas right now under the modules for week 3, uh, the very first thing there is Flappy Bird Assets. It's a GitHub page. If you just want to download that zip file real fast, so you've got that if you'd like to follow along on this. And he's fairly easy to follow. If you have not, if you didn't have 120 with me last semester, his accent's a little thick and it's a little hard to follow from time to time, but not to a point that it's going to like derail you or anything like that. I've definitely heard people with much harder to understand accents before. And he actually is quite a bit easier to understand in the second second series we're going to watch after this. So, all right, let's check out this first Flappy Bird tutorial.
Okay, so hello and welcome to this tutorial. In this tutorial, we'll teach you how to make a Flappy Bird game. So the Flappy Bird game will look something like this. We'll have a bird that flaps, and every time we go through the pipes, we will add 1 to the score. So if we hit the pipes or the ground, it will be game over for us, and we will have a replay button to play the game or to replay the game as many times as we want. So this is the game that we will be making. So let's get started. So to start making this game, we need to create a new Unity project. So to do that, let's go to Unity Hub, open Unity Hub, and let's create a new project. So click here, new, and let's select 2D because our game is going to be in 2D. And now let's give our game a name. So I'll call it Flappy Bird like this, and hit create. Now Unity will start creating the default template for our project. So we will have to wait a minute or so. And now here we will have the main editor. But if it is the first time that you open Unity, it may not look like my editor over here. This is because I have personalized my own editor. So if it's the first time you open Unity, it would look something more or less like this. But what I like to do is that I like to drag the hierarchy to the right. So you can left click and drag to the right and position it over here. And then I like to put the game to the left. So go to the game tab and now just place it here to the left, and we will have the scene here at the center. So we have the inspector here to the right, and we have the project view here at the bottom. Okay, so the first thing that we need to do is that we need to add the sprites for the game. So I have my sprites in my desktop. I have them in a folder. You will have the sprites attached to this lecture. So just let me find my sprites, and I have my sprites over here. So now that we have our sprites, what we need to do is that we need to select them here in Unity, and then we have to select multiple for the sprite mode, okay, because we have multiple sprites. And then what we're going to do is that we're going to set the filter mode to 0.0 filter and the compression quality to none, and then we're going to hit apply. And now when we're going to hit the sprite editor, and we're going to hit slice here at the top and slice again, and then we're going to hit here apply. And now we can see that we have sliced our sprites in individual sprites like this one. So make sure that every single sprite is individual. And now we're going to close this window. And now what we can do is that here in the assets, we have the sprites, we can click this arrow and we can see that we have the individual sprites. So if I select, for example, the background, you can see a preview of the background here in Inspector. And what we can do is that we can drag this background to the hierarchy. And in the hierarchy, we just have a main camera and now we have a background. So let's rename this in the Inspector. This is the name of the game object. Let's rename this to BG. And you can see that we have a problem here. We can see that the background is very, very small. So first of all, let's set the resolution for our game. Right now, if you take a look at the game view, you can see that it says free aspect. We're going to change this. So click here and we're going to change it to 9 by 16. Okay. If you don't have this 9 by 16, you can add it here. You can click this plus icon and you can change the type to aspect ratio. And here you can type in 9 by 16 and you can name it 9 by 16 because this is going to be the aspect ratio that we're going to work with, and then click OK. I'm not going to do it because I already have it, so I will click cancel. Alright, so now that we have the background, what we're going to do is that we're going to make all of our sprites bigger. Okay, we're going to make them bigger. And how do we make them bigger? We're going to select the sprites here in the project, and here you can see that there's a field called pixels per unit here in the Inspector, and it's set to 100 pixels per unit. We're going to change this to 25 pixels per unit, so we're making the sprites 4 times bigger. Okay, and now we're going to hit apply here, and you can see that now the background fills all of the camera space, which is nice because our sprites are now bigger. Alright, so now let's go ahead and drag the ground. So select the ground with left click and drag it to the hierarchy. Let's rename this to ground. And now if you hit W on the keyboard, you will see that some guides appear here, so you can drag the ground vertically down like this. Just place it in the right position. And now what we have to do is that we have to drag our bird to the scene. So to do this, left click the bird here in the project view and drag it to the hierarchy. Let's rename this to bird. And we're going to do the same thing. We're going to move the bird a little bit to the left and position it accordingly to the sprites. Okay, so now that we have the sprites set, now if we hit play, we will play our game. But if we hit play, nothing will happen. And another thing happens, and it's that the ground is now behind the background and the bird is behind the background. Okay, so why does this happen? This happens because if we select the background, you will see that it has an ordinary layer of 0. And if we select the ground and or the bird, they also have an ordinary layer of 0. So just like in Photoshop, here we have layers. So what we can do is that we can select the ground and we can assign an ordinary layer of 2 to the ground. So now the ordinary layer of the ground is bigger than the ordinary layer of the background, so we'll render in front. And we will give the bird an ordinary layer of 1, so it renders in front of the background but behind the ground, because the ground has an ordinary layer of 2. So now if you select the bird and you drag it, then you will see that it renders in front of the background but behind the ground. Okay, so that's going to be it for this video. I'll see you in the next video. Okay, so one thing I forgot to mention in the previous video is that you can zoom in or zoom out using the mouse wheel, okay? So you can use the mouse wheel to zoom in or zoom out. Alright, so now in this video, what we're going to do is that we're going to add some physics to our game. Because right now, if we play our game, nothing happens. Everything stays the same way. So what we're going to do is that we're going to select the bird, and here we're going to add another component. So click here and add component in the inspector, and let's type in rigid body 2D. So there's rigid body and there's rigid body 2D. Make sure you select rigid body 2D, okay? So select rigid body 2D, and now if we hit play, you will see that the bird is being affected by gravity and it falls down to the infinite. This is because this rigid body has a gravity scale of 1, and that's the reason why the bird falls down. But we don't want the bird to fall down through the ground. We want the bird to actually collide with the ground. We want the bird to be able to collide with the ground. So to do this, we need to give the bird a collider. So let's add another component and let's type in capsule collider 2D. So now if you take a look, if you zoom in, you can see that the bird now has like a circle surrounding it. Okay, so what we're going to do is that we're going to go to the capsule collider component and set the direction from vertical to horizontal. And now you can see that it looks more like a capsule and it fits the bird quite nicely. But one thing that we can do is that we can hit the edit collider button, and now you can see that some spots, some little squares have appeared, around the collider, and we can just click on them and drag the collider like this, so we can make the collider fit the bird a little bit better. So like this, it's perfect for now. And now that we have added a collider to the bird, if we press play, you will see that the bird still goes through the ground. So why is this? This happens because the ground also needs a collider. So let's select the ground, let's add a component, and for the ground we will add a box collider 2D. So add a box collider 2D, and now if you zoom in, you will see that the ground has a green outline, the green border, which is the collider. Now we hit play, you will see that the bird collides with the ground. So we have added physics to our bird, and we have added colliders to the bird and to the ground. So that's going to be it for this video. I'll see you in the next video. Okay, so far it's good. We have added some physics to the game, but we want to make the bird flap every time we touch the screen or every time we click the left mouse button. So to do this, we need to add a behavior to our bird, and a behavior in Unity. We create a behavior in Unity by creating a script and attaching it to a game object. So let's do that. Let's go here to the project view, and first of all, we will right click here and select create folder, and we will call this folder sprites, and we will drag the sprites to the sprites folder. And now we will create another folder. So right click, create folder, and we will call this folder scripts. And now we will double click inside the scripts folder, and we will right click again and select create C# script, and we will call the script bird. Remember to name the script with a capital letter, because that's the convention in programming. So make sure it's bird with an uppercase B. And now let's double click this bird script, and now Visual Studio will open. So now we can edit the script from the Visual Studio editor. Okay, so for the bird, what we need to do is that first of all, we need a speed for the bird. So public float speed. This is a variable of type float, which means that it's a decimal value, and it will be public because we will set the speed from the inspector. And we also need to access, if we select the bird, we can see that it has a rigid body. So we want to access this rigid body component from the script. So how do we do this? We do this by creating a variable of type rigid body 2D. We can call it whatever we want. I will call it RB. And in the start method, we will set RB equal to get component, open angle brackets, and then we will say box collider 2D, sorry, rigid body 2D, because we want to access the rigid body 2D. So now this RB is equal to the rigid body 2D of the bird. Now what we can do here in the update method, this is a method that runs every frame of the game. So here we want to keep checking every frame of the game if the user has used the left mouse button. So if the user clicks the left mouse button, then we want to make the bird flap. So here we can say if input dot get mouse button down, and then we open and close parentheses, and inside we put a 0. So if the user, this means that if the user uses the left mouse button, then we want to flap. And this is just a comment, so this means nothing. Unity will ignore this, but it's just a comment for me to know what we want to do. So we want to flap. So the way we flap is that we say rb.velocity equals, and this rb.velocity has to be equal to a vector2. A vector2 has a x component and a y component. So we want the rb.velocity be equal to vector2.up times speed. So speed is a value that we haven't defined yet, and vector2.up is the same way as saying 0, 1. Because we don't want to move along the x-axis, it's a 0. We want to move only in the direction of the y-axis. We only want the bird moving up or down. So we multiply vector2.up times speed. So now we go back to Unity and we select our bird. What we have to do is that we have to give it the script. So we can add a component, and we can just go here to the scripts folder and just drag the bird script here to the bird, and you will see that we have attached the script to the bird. And we can see here that we have a field for the speed, so we can edit it from here. We will set a speed of 4 for now. So save everything.
Real quick, I want to mention he has access to that field because he made it a public. He made it public in the script, which means that the Unity engine can see it. So he can actually get that little field there to add the 4 in instead of having to code it in raw or something like that.
Play the game and you will see that we can click here in the game view and we can make the bird flap, which is great. Alright, so now one thing that we can do to make the bird look a little bit better is that we can animate the bird so it looks like it's flying. So to do this, just select the bird, and now what we're going to do is that we're going to go to Window, Animation, and we will see that this window pops out, and we're going to drag this animation window here, down here, and we're going to drag it to the right like this. So we have the project view and the animation window over here. So to create an animation is very simple. We select the game object that we want to animate. I want to animate the bird, so select the bird and then hit create. So now it will give us the option to give a name to our animation. But before doing that, let's go here up to the assets folder. So click here where it says assets, and here we're going to create new folder. So animations, we're going to create a new folder called animations. Double click in the animations folder, and inside here we're going to create a new animation. So the name of the animation, we want it to be bird because it's going to be the bird animation. So save it, and now you will see that here in the animation view we have a timeline. So here we will create our animation, and now what we have to do is that we have to give our animation some sprites. So let's go here in the project view to the sprites folder, click this arrow, and here we can see that there are 3 sprites of the bird. If we select the first sprite, we can see a preview of the sprite here in the inspector. So what we can do is that we can drag the bird sprite here to the timeline. So it will be a position 0, 0, but here you cannot see anything. So you have to go to this arrow over here and click it. And now you can see that we have the sprite of the bird, the first sprite of the bird here at position 0, 0. Okay, so now we need the other sprite. So let's select the other sprite of the bird, which has the wing at middle position, and let's drag it to 0.1. For example, and let's drag the third sprite of the bird to position 0.2. If we click play, we will see that there's an animation of every frame of every sprite of the bird. Okay, we can make the animation a little bit smoother by just selecting this sprite here in the animation view, the second sprite. You can see that it's selected because the diamond has become blue. Then hit Ctrl C on the keyboard to copy it, and then if you click anywhere here in the timeline where the numbers are, you can see that the white line is moving. There's a white line that is moving, so you can click on the 0.3, so the white line is right on the 0.3, and then you can hit Ctrl V and you will copy the sprite that you have copied. And now we can do the same thing with this sprite with the first sprite that we attached to the animation view, and we can just hit Ctrl C and go to 0.40 and hit Ctrl V. So now if we press play, you can see that the animation is way smoother, but there is a problem, and it's that the animation is very slow. So one way that we can make the animation a little bit faster is by selecting the first sprite, hold shift and select the last sprite, and now we can drag the animation like this so we can make it faster. And if I hit play, you can see that the animation is faster. If you want it a little bit faster, you can drag it a little bit to the left and you will see that the animation is faster. Now that we have finished with the animation, we can drag the animation window back to here, and now we hit play. You will see that the bird is moving, it's flying, and we can play with the bird like this. We can flap and the bird is flying. Okay, so that's gonna be it for this video. I'll see you in the next video. Okay, so now in this video we will make the ground move to the left, because right now we have our bird flapping, but our ground is still, and we want the ground to move to the left while the bird is flapping. So to do this, we need to create a new behavior for the ground. So let's go to scripts and let's right click and create C# script, and let's name this script move left with the capital M. Okay, so move left, capital M, and just double click it to open it in Visual Studio. And for the ground, we will need a speed. We'll make it public so we can edit it from the inspector. So public float speed. Okay, and now here in the update method, we're going to update the position of the ground to the left every frame of the game. So to do this, we're going to say that transform the position of the ground is going to be equal to a new vector2. Okay, so when I say transform dot position, what I mean by this, if you go here and you select the ground, you can see that the ground has a transform. a transform component, and it has and the transform component has a position on the x and on the y. So we want to edit the position on the x-axis, okay? So we want to say that the transformed position of the ground is equal to a new vector 2, which has as the x component the transformed position dot x minus speed times time dot delta time. So the speed is the amount of units that we want to move to the left, and we multiply by time dot delta time because we want to move this amount of units in 1 second. If I didn't multiply by time dot delta time, then I would be moving this amount of units every frame, and that is a lot. That is very, very fast. So I don't want that behavior. What I want to do is that I want to move this amount in 1 second. That's why I multiply by time dot delta time. And now for the y component, I want to do nothing, so I just leave it as it is. So transform the position dot y, like this. I don't want to update transform the position dot y of the ground. I want to update the transform the position dot x. So I take away the speed times time dot delta time. So every frame I will take away a little bit of the speed. Okay. So now we will be moving to the left. We can save the script by hitting Ctrl S, go back to Unity, and if I hit play, you will see that nothing happens. This is because the ground doesn't have the script attached to it. So let's attach to it. Let's attach the move left script to the ground. So you can drag it, or you can add the component and you can look for move left. You can do it both ways. So now let's give a speed to the script. Let's give a speed to the ground. Let's give a speed of 2. Let's give it a speed of 2 and let's hit play. And now you will see that the ground moves to the left. Okay, perfect. So now what we can do is that we can select the ground and hit Ctrl D. So now we can move this copy up here a little bit. So we have ground and ground 1. And I want to position ground 1. So select ground 1. I want to position it right next to ground, to the first ground. But I want to position it exactly to the right. So just where the first ground ends. So to do this, we can select the ground and we can see that in the box collider component, it has a size of 6.72. So this is the size in Unity units of the ground. So what I can do is that I can select the ground, the copy, the other ground, ground 1, and I can set it in position X to position 6.72. So I will place it right next to the first ground. Okay, if I hit play, you will see that now we have both grounds moving to the left, which is amazing, but the grounds, there are no more grounds left, so we have to fix that somehow. So we want to reposition the ground. So what we want to do is that when the first ground gets to position minus 6.72, we want to move it 1 like this. We want to move it, so we want to move it its length to the right and another time. So we want to move it its length by 2 to the right, right? So we have to do that via script. So how do we do this in the script? So to fix this in the script, so first of all, let's fix this because here you can see that both grounds are not at the same position. So let's type in a position for both grounds along the y-axis. So it's going to be -4, and for the other one it's going also to be -4, just so they are in the same y-axis, right? In the same position on the y-axis. And now let's go to the script, and in here we are moving to the left, and we're going to check. We're going to say if transform dot position dot x is less than or equal to minus ground length, then we want to say that transform dot position is equal to new vector 2, and we want to modify the transform dot position dot x. So transform dot position dot x plus 2 times ground length, and the transform dot position dot y, we don't want to do anything to it. And this ground length appears in red and it's giving us an error because it's saying that ground length does not exist in the current context. So we need to define this ground length. So we're gonna go here, up here, and we're going to say we're going to create a variable of type float called ground length. Let me see if I can type it correctly, like this. And now we don't have the error anymore, but we need to know what this ground length is going to be. So here we can see that the ground length, we want the ground length to be equal to the size of the collider on the X component. So we need to access this box collider to get this data. So in the script, we're going to get a reference to the box collider by just declaring a variable of type box collider 2D, and I'm gonna call this variable ground collider. And in the start method, I'm going to say that ground collider is equal to get component box collider to D. So we get access to the collider. And then we're going to say that the ground length is equal to the ground collider dot size dot x. So we're saying that the ground length is equal to the ground collider to the collider dot size dot x. So it's going to be equal to 6.72. So when the transformed position dot x is minus less or equal to minus 6.72, then we want to reset the position to 2 times its length to the right. Okay, so now if I hit play, we should see that when the ground gets to position minus 6.72, it repositions to the right, and it works perfectly fine. Okay, so now we have a moving ground, and that's going to be it for this video. I'll see you in the next video.
Okay. There are a few more videos left in this series, but I wanted to make it through the whole thing, but we've been going for a little while, and I want us to have a chance to have a break. So come back at 10 o'clock, and we will continue with this series and wrap it up and everything, so that you can hopefully not have to work a ton on homework between now and next time. Okay, so something that I'm going to try to set up. Here we go. Something that I'm hopefully going to try to set up. And this isn't relevant to you all that are um, present in class. This is for those who are watching it elsewhere. Um, but I'm going to incorporate, if there's stuff that's going to come after the break, I'm going to incorporate the break into the live stream. I'm going to have a countdown timer, everything like that. That way, if anybody needs to, if they want to take a break at home or whatever, they know how much time they have before they can come back in, and that sort of thing. Oh shoot! I closed the window I meant to have open. Sorry. Give me just a second. Nope. Sorry, I'm normally more with it than this.
It's not necessarily a question of having to
Okay, so far it's good. We have added some.
Here we go. Okay, so we are ready to add pipes to our game now. So our bird can flap. He's animated, so he flaps, and he can fly. Whenever we click the mouse button, he'll go up a little bit and then slowly fall back down due to gravity. Now we can start adding the pipes. That way, he's got something to run into in order to, other than the ground, in order to lose the game. Or if he successfully clears one, it goes through a set of pipes, it adds one to your score. So let's check that out.
Okay, so in this video we will add some pipes to the game. And to do this, we will go to our sprites and we will select the pipes. So drag one pipe to the hierarchy and drag the other pipe to the hierarchy. So we have both pipes. And now we can rename both pipes. So I'll rename the first one to pipe 1 and the second one to pipe 2. Alright, so now what I can do is I can select one pipe and drag it upwards and the other pipe and drag it down like this. Just place them where it feels right, and we'll place them over here like this. And now what we need to do is that we need to create another object that will act as the parent of both pipes. So when I move that object, I'm able to move both pipes. So to explain what I mean, or to explain it better, what I'm going to do is that here in the hierarchy, I'm going to right click, create empty, and when I create an empty object, you can see that it only has a transform component with a random position. So to reset the position, let's right click here in the transform and hit reset. And here let's change the name to column. So this is going to be our column object, and now we're going to place the column at the, you can select the column here and we can place it wherever you want to. I'm going to place it right in the middle of the two pipes, and what I'm going to do is that I'm going to select the first pipe, hold shift, select the second pipe, and drag both of them to the column like this. And now the column is the parent of the pipes and the pipes are the children of the column. So now if I select the column and I move the column, I move the pipes with the column, which is what we want to achieve. Okay, so now that we have the column, one thing that we could do is that we could try and move the column to the left. We already have a script to move game object to the left. We have our move left script. So let's select the column and let's attach the move left script to it. Let's add a speed of 2, and now we hit play. You will see that the column moves to the right, but it appears that the pipes are being rendered behind the background. This is because if we select both pipes with shift, you can see that the ordinate layer is 0, so we can change it to 1. And now if we hit play, you will see that the pipes are in front of the background. Okay, but if we stop the game, we can see that we are getting an error here at the bottom. If we go to the console, here we can see the errors that we get, and it says that there is no boss collider attached to the column game object, but the script is trying to access it. If you remember, what we did in the move left script is that we were trying to access the boss collider, but we wanted to do this because we were trying to access the boss collider of the ground, remember? But the thing is that the column doesn't have a box collider. So how can we differentiate so that we only want to do this if we are the ground? So we don't want to do this code. We don't want to execute this code if we are the column. So how do we do this? So what we're going to do to solve these problems, there are many ways to solve this problem, but what I'm going to do to solve this problem is that I'm going to just select any game object, and here in inspector we have a tag field. So click here, and here you can see that we have some tags already, but we're going to hit add tag, and then we're going to hit the plus icon, and we're going to type in a ground tag. So just type in the word ground and then save. And now we're going to type in the word pipe and then save. And we're also going to create another tag called column and then hit enter or save. And now we have three tags. We have created three different tags. So what I'm going to do is I'm going to select both grounds, and I'm going to attach or set the ground tag to them like this, and then I'm going to select the column and set the column tag to it. Okay, so now let's go to the script again, and in the start method we're going to do this code if the game object has the tag ground. So here we can just say if game object dot compare tag, open and close parentheses, and inside the parentheses we're going to say if this is the ground. So we're gonna open and close quotation marks, and inside we're gonna put the name of the tag. So this name has to be the exact same name as the tag that we created, okay? Because if you put this with a lowercase g, then it's not going to work, okay? So it has to be the same. So if the game object has the tag ground, then we want to do this code over here. So if we are the column, this is not going to run, so we won't get an error. And we only want to reposition the ground if we are the ground. So if game object dot compare tag, we're gonna do the same thing, ground. So if we are the ground, then we want to reposition the ground, or we want to be checking if the position.x is less than minus ground length. All right, so now save that, go back here, and if we play the game again, you will see that we don't get the error because we are when the column is moving, this code over here is not executing, and this code over here is not executing. Okay, so that's going to be it for this video. I'll see you in the next video. Okay, so right now we have a column and it's going to the left, but what if we want multiple columns going to the left? So one way I could do it is I could just hit Ctrl D on the keyboard and create many copies of the column, but an easier way to do this manually is to actually go to our project. We will go to our assets and right click here, and we'll create a new folder, and we'll call this folder prefabs, and just click here in the prefabs folder, and what we can do is that we can drag this column, so drag the object to the prefabs folder, and now you will see that it turns blue. So this is because this column has converted itself to an instance of a prefab. And what is a prefab? Well, a prefab stands for prefabricated object. So when I drag the column to here, to the prefabs folder, I created a prefab. This means that now I can go ahead and delete this column, and now I have my prefab here in the prefabs folder. So I can just drag this column to the hierarchy as many times as I want, and I can create as many copies as I want manually. So you can see that we have three different columns, and I can position them however I want to in the scene, and we can play the game, and you can see that we have three different columns like this. They are not very well arranged, but we have three different columns. But we want to do the same thing, but we don't want to do it manually. We want to do it from the script when we start the game, right? So let's get rid of the columns. We can get rid of the columns. So what I'm going to do right now is that we're going to create a new object called column spawner, okay? So right click, create empty, and let's rename this object to column spawner like this. Let's reset the transform, and now we have an empty object, and what we're going to do is that we're going to create a new script for this empty object. So let's go to scripts, right click, create C# script, and let's call the script column spawner like this. And now we can select the column spawner, we can add the component, click here add component and select column spawner. And now let's open the column spawner in Visual Studio. So now what we want to have in this script is that we need a reference. We need a reference to the prefab, to this prefabricated object. So how do we do this? We say here public game object column prefab like this. So this will be a reference to the prefab. And here in the start of the game, we want to spawn a column, right? And here in the update method, we want to spawn columns every X amount of seconds. So now we need to define the functionality to spawn a column. So to do this, we're going to go, and after the update method, here we're going to define a new method. We're going to call this method void spawn column, and we're going to just, this is a method. It's going to be of type void because it's not going to return anything, and it's not going to receive any parameters. So that's why the brackets, there's nothing inside these brackets. It's empty. Okay, so inside here we're going to say game object new column. So we're creating a variable of type game object, and this is the name of the variable new column, and it's going to be equal to instantiate. So instantiate means make copy of. So we're making a copy of, we're gonna want to make a copy of this column prefab. So instantiate column prefab like this. Now that we made a copy, we create a copy. What we're going to do is that we're going to set the transform.position of this copy. And what we want to do, if you select the column spawner, we can see that the column spawner is at position 0, 0, but we can drag the column spawner here to the right. And here we can see that this is our column spawner, but if I hit anywhere here, if I click anywhere else in the scene, we can see that we can no longer see the column spawner. So to be able to always see the column spawner, what we can do is that we can select the column spawner, go here in inspector, click this cube over here, and we can click this diamond, for example, and now this diamond is going to be where our column spawner is. So if I click anywhere else in the scene, you can now see where the column spawner is. So let's create a prefab of the column here, and here you can see that these are columns. So we want our column to be spawned at this position. So we want the column to be spawned at the position X of the column spawner, and we want a random position for the Y, because we don't want the Y position to always be this position. Sometimes it will be this position, sometimes it will be this position, right? We want a random value for the Y component of the position of the column. Okay, so now that we know this, let's try to figure out what would be the correct Y position. So you can see here that in the inspector we have the Y position of the column. So maybe we could set 2.7 as the maximum for the column, and maybe minus 0.5 as the minimum. Here you can see that in the inspector you can see that this is the value. So maybe between minus 0.5 and 2.7, we can create a random value between those two values for the column. So we can get rid of the column, go back here in the method. So here we're defining the position of the new column. So we're going to say new column dot transform dot position is going to be equal to a new vector 2, and we want the position on the x-axis to be equal to the transform dot position dot x-axis of the column spawner. So that's why we leave this like this, because we don't want to change that. And here we want a random y pos. So I'm going to call the y component, I'm going to call it rand y pos. So rand y pos is going to be a variable that we're going to define at the beginning before creating the copy of the column. We're going to say float rand y pos is equal to random dot range. So random y pos is going to be equal to a random value. So random dot range is a function that will return a random value between a minimum and a maximum. If you hover the mouse here over range, you can see that there's a box that appears and it says float min, float max. We need to give it a minimum value, so min y, max y. And we haven't defined this min y and max y. We want to define them from the inspector, so we're gonna make them public here. At the beginning, we're gonna say public float, and we're gonna type in min y, so min y, comma, max y, like this. So I have defined both variables in one line. So now we want to spawn the column. Let's start by spawning the column at the start of the game. So spawn column, like this. And now let's go back to the Unity editor, and now we can see that if we select the column spawner, we can give it a min y. So for the min y, we want minus 0.5, and for the max y, we want 2.7. And now we have to give it a reference to the column prefab. So go to the prefabs folder and drag the prefab to the reference to the column prefab. And now if we hit play, you will see that we spawn a column, but we only spawn one column because we are only calling this method from the start. We want to also be able to call this method every X amount of seconds. So I'm going to create a timer for that. So float timer, and I'm going to create a public variable of type float called max time. So the idea behind this is that when timer is greater than max time, we're going to spawn a new column, and then we're going to set timer back to 0. So here in the update method, we're going to say timer plus equals time.delta time. So time.delta time is the time in seconds that each frame lasts to render. So if one frame lasts 0.15 seconds, then that's going to be the value of time.delta time. And we're going to be adding this value to timer every frame, and we're going to check every frame if timer is greater or equal to max time. And if it is, we're going to spawn column, and then we're going to set timer back to 0. So this is the main idea that we want to happen in our game, okay? So now let's go back to the Unity editor, and now we have a field in the column spawner, in the column script. In the column script, we have a field for max time. So let's set it to 1.5, for example. And now if we hit play, you will see that every 1.5 seconds, we will spawn a new column. Perfect. Everything's working perfectly. And everything's working the way we wanted. But if we pause the game, we will see that there is a problem. And the problem is that the columns don't disappear. They never disappear. They are created and they move to the left and they never disappear. So how do we fix this? We can fix this very easily by going to the move left script, and here we're going to check if we are a column. So here we're going to say if game object dot compare tag column. So if we are a column, we want to destroy the game object, because we want to destroy the column when the column gets to this point, more or less. So let's drag a column just to see where we want the column to be destroyed. At position -4, maybe on the x-axis, maybe that's a good position for the column to be destroyed. So let's delete this column, we don't need it anymore. And inside here, we're going to say if transform.position.x is less than or equal to left limit. I'm going to create a variable called left limit, and then I'm going to say if this is true, then destroy game object. I'm going to destroy the column. So we need to define this left limit. So we're going to do it from here. We're going to say public float left limit, and I'm gonna set this left limit from the editor, from the inspector, from the editor. So I'm gonna select my column, and you can see that if you select your column prefab, you can see that here in the move left script you have a left limit field. So we're gonna set it to -4. We said. Now we hit play. Every time the columns are at position -4, they're gonna be destroyed, and every time they get to -4, they are destroyed. You can see that happening in the scene. Okay, so we have, I think that for this video it's enough. I'll see you in the next video. Okay, so our game is working perfectly fine, but the only thing that we don't have is a score. We want to be able to add 1 to our score every time the bird goes through the pipes. So to achieve this, we're going to create a canvas with a score. So let's right click here in the hierarchy and select UI, and we will select canvas. And when we select the canvas, you can see that we have created an event system. And if you double click in the canvas, you can see that this is the canvas, okay? So this is the canvas, and for example, if you now double click in the background, you will see that this is the game. So what we're going to do is that we're going to select the canvas, and we're going to select the render mode here, and we set it to screen space camera. And now we have to give it a camera, so we're going to drag the main camera to this field. And now what we're going to do is that we're going to set an ordering layer for the canvas, and we're going to set it to 10 because we want the canvas to render in front of everything else. Now here where it says canvas scaler, we're going to set the UI scale mode. This UI scale mode, we're going to set it to scale with screen size. And now we have to give it a reference resolution. Let's give it a reference resolution of 900 by 1600. Why 900 by 1600? Because it's the resolution that we're working with, 9 by 16. So that's why we put 900 by 1600. And this screen match mode, we're going to set the match to 0.5, okay? And now that we have done this, we're going to right click here in the canvas, select UI, and we're going to select text. and we're going to rename this text to score text. I'm gonna call it score txt, and we're gonna set the text to 0 because this is going to be our score. And let's set the alignment to center and center, and the horizontal overflow to overflow, and the vertical overflow to overflow. And if you zoom in here in the scene, you can see that if you select the score text, you can move the score text up like this. We will move it up here, and now we can change the size. So let's change the font size here in the inspector by dragging to the right like this. Perfect. We're going to change the color of the score. So change the color of the score to white. Click here and change the color. And now we're going to give it a shadow. So add component, and let's type in shadow. And if you zoom in, you can see that we cannot see the shadow, but it is because we need to play with the effect distance. So click and drag to the right, so the shadow goes to the right. You can see that the shadow here in the scene goes to the right. And we can also play with the Y component, so we can make the shadow go up or down by dragging right or left. Okay, I'm gonna drag it up, so the shadow is to the right and a little bit up. So now we hit play, we'll see that we have the score, which is very nice. But every time we go through the pipes, we don't update the score. Why is this? This happens because we need to actually detect that the bird is going through the pipes. So let's drag one column just to see what we want to happen in the game. And what we want to do is that we want to create a collider so that when the bird collides with it, we trigger something, we trigger an event, and then we add 1 to the score. So we're going to select the column, add component, and we're going to add a box collider 2D. And we have this box collider 2D, but we want to change the size a little bit, so we can drag the size to the, we can click and drag the X to make it, we'll make it a little bit smaller on the X axis and bigger on the Y axis like this. And we can play with the offset, we can drag it to the right, so the collider moves to the right. We're gonna place it right here to the right. So when the collider of the bird collides with this collider, we want to trigger something. So we don't want the bird to collide with this collider, but we want the bird to trigger this collider. So we're gonna set the is trigger to checked. We're gonna check the is trigger option of the box collider, and you can see that now there's like a plus icon. This is because if we now select our column prefab here in the project, you will see that it doesn't have the box collider that we just created. But if you select the column instance, you will see that it has the collider. So this is because we have only modified the instance but not the original prefab. So to affect all of the, so if you want to apply this change to the original prefab, what you need to do is that you need to go here to overrides and select apply all. Okay, so now this column has a collider and it also has a tag column. So what we can do is that we can delete this column and we can go to the bird script in the Visual Studio, and after the update method we're going to define a special method called onTrigger. So typing onTrigger, and when you see onTrigger enter 2D, hit enter. And this is a special method because this method is going to listen for trigger events that happen with the bird. So here we're going to say if collision, if this is the event that we're getting, so this is the collider of the object that we're colliding with. So we're going to check if collision.gameObject, or we can just say if collision.compareTag, open and close parentheses, and we're gonna type in here column. So if we collide with the column, if the bird collides with the column, if it triggers the column, then we want to score. So we want the score to go up. So we're gonna print for now, and we're going to say score up. This print method will print this text to the console when this happens, okay? It's just so we're printing something just to test out this and see if it works. Now, if we go back to Unity and we try to play the game, we're going to see that if the bird collides with the column, we should see something appear in the console. And if we stop the game and if we go to the console, we can see that a score up has been triggered. So this trigger method is working and this is happening. So we are doing a good job so far. Okay, so now we need to create a new behavior for the score text so that we can update this score text every time we score. So to do this, let's go to the scripts and let's right click, create a C# script. We will call this script score, capital S, uppercase S. Let's open it. And the first thing that we're going to do in this score script is we're going to create an int variable of named score. Okay, so this is going to be a number, an integer, and at the start of the game the score is going to be equal to 0. And then we don't need this update method, so let's get rid of the update method, and we're going to create a method of type void called score up. and we're gonna call this score up method every time we score. And we're gonna make it public because we're gonna make this method public because we want to access the score up from the bird script. We want to call this score up from the bird script, okay, from here. So when we trigger the column, but then we want to call this the score up. So inside the score up, we're just going to say score plus plus, which is the same thing as saying score is equal to score plus one. And then we want to get access to the text component, because if you select the score text, you can see that the score text has a text component. So we want to select this component. This is because the score script is going to be attached to the score text. So let's add the component and let's look for the score. And let's add it. Let's hit enter. So the score script is attached to the score text. And from this script, we want to access the text script, the text component. So here before we can say that, we have to use a Unity library called UI. So using Unity engine dot UI. Okay. So we need to do this so we can use the text type. Okay. So here we're going to say, after we add one to the score, we're going to say get component text dot text, because we want to access the text.text, and we're going to set it equal to a score to string like this. So why text.text? Because the score text has a text component and the text component has a text field. So that's why I'm saying text.text equals score, which is the score, to string, because the score is an integer and we cannot assign an integer to a text. But if we transform the score to a string, then we can assign it to the text. Okay, so now the only thing that we need to do is that we need to call this method from the bird script. So to do this, we're going to create a reference. So I'm just going to comment this and say that these are the references. And we're going to create a reference that is going to be a public reference to the score text. So this is going to be a score text variable of type score. And now what we're going to do here is that when we score, we're going to say score text dot score up. We're gonna call the method, but we have to set, for this to work, we need to set this reference from the editor, from the Unity editor. So now in inspector, we're going to select our bird that has the bird script, and it's waiting for the reference to the score text. So let's click and drag the score text to the score text. Now this is done, and now every time we go through the pipes, we should be calling the score up, and we should be updating the score. And one thing that you can see that we can go through the pipes, and this is not a good thing because we can go through the pipes and we can avoid scoring up. So to do this, let's go to the prefabs folder. Let's double click the column. So now we have opened the prefab editor, and in the prefab editor, you can see what the prefab is made of. The prefab is made of a column and two pipes. And if you select the pipes, you can see that they don't have a box collider. So we're going to select both pipes and add component box collider 2D. So now we have added a component to the original prefab, so we don't have to override anything because we have edited the original prefab. So now we can click here in this arrow to go back, and now we hit play. You can see that we can actually collide with the pipes. And one thing that you can see that is that if the bird collides with the pipes, it can rotate. The bird can rotate like this, and we don't want if you don't want the bird to rotate, what you can do is that you can select the bird, and here in the rigid body component, you can click here where it says constraints, and you can freeze the Z position. So now we play the game. You can see that whenever the bird collides with the ground or with the pipes, it will not rotate on the Z axis. Okay, so that's going to be it for this video. I'll see you in the next video.
Okay, so what might you guess is the final couple of things that you need to do? Like based on what we've already done, what might you need to do to wrap up? What would be your hunch would be the final things that he discusses? I can fly, I can score. What happens if I hit the ground or the pipe? Yeah, and restart, exactly. Okay, so what I'm going to do is I'm going to put up on Canvas a link to this playlist so you can watch the final bit on your own. So between now and next Monday, you need to follow that to the letter, at least till you get that part done. Follow it to the letter and make that game. Now, I will offer you 10 bonus points if you alter the game in some noticeable way. In other words, use a custom font, change the sprites, the sprite of the bird, the sprite of the columns, the background, add sound or music. There are tutorials that explain how to do that. Now, I'm not looking for you to go out and go crazy with it, but if you want those 10 extra bonus points, do something a little fancy with it, okay? We have about 45 minutes-ish remaining, so that I would imagine that you can at least make a decent dent in this project, as well as the other one, the age calculator thing. I'll put that up on Canvas for you with the details and everything. Are there any questions, concerns, comments, thoughts, ideas? Yes, sir.
What about that simple thought project that's on Canvas?
Yes. I'm glad you brought that up. Let me flip over real quick and bring that up. Did we discuss that in class? That was the day we didn't have class, right? Is that correct? Okay. So what I'm wanting is just a simple input-output program. Now, what we're simulating is a chat bot with AI, okay? So let me do this and zoom in a little so we can see what's going on here. Okay. So I said use C# to create a program that allows the user to input their name, date of birth, and list of pets and stores them as variables, okay? Now, the reason that I had you do this is build on the thing I'm having you do today, which is just the age calculator, okay? So I'm kind of having you do it in reverse. But it'll ask, so when they load the program up, it'll say, hi, what is your name? You put your name in. What month were you born in? What day and what year, that kind of thing. How many pets do you have? Okay. Now, for simplicity's sake, you could skip the how many pets do you have and just say, like, what is your pet's name? Or something like that. If you'd like to do multiple pets, you need to iterate, how many pets do you have? I have 5. Number of pets equals 5. While number of pets is greater than 0, ask, okay, what's pet number 1's name? Do you understand what I'm saying? We did that last semester. You don't have to get too complicated with it, okay? All I'm looking for is testing is the input equal to something you're looking for, okay? So I should be able to say, what is my name, okay? And then you should have if input dot lower, right, is equal to what is my name, then it will say your name is, and print out their name. Does that make sense? Okay. Now, don't stress about this too much, okay? I'm just trying to get you into Visual Studio, and I'm trying to get you to mess around with input and output and variables and things like that, okay? So you will get the points on this if you attempt it, okay? And until we get to second year, that's pretty much the case always, right? Just make an attempt, pay attention, do what I ask you to do, and you'll get the points. Now, once we get to second year, it gets a little bit more complicated, and you do actually have to start kind of thinking for yourself, as it were. But just do this to the best of your abilities, and we will discuss it further and answer any questions and comments and concerns on Wednesday. Okay? Great question. Thank you for asking that. Any other questions, comments, concerns, thoughts, ideas? No? All right. In that case, I will turn you loose to start working on the age calculator, the simple chatbot. If you don't have it done, I'll extend the due date on that one as well, and the